The title of our paper is iTrails, Pay-as-you-go information integration in Dataspaces. My name is Marcos Vassales. I'm a PhD student of Jens Dietrich at ETH Zurich. This paper was done in collaboration with other colleagues from ETH. The problem we're looking at is the problem of querying several sources. Suppose you have a number of data sources which contain structured and unstructured information, such as a laptop, an email server, a web server, a database server. Each of these data sources is accessed by a specialized system. The query we want to answer is, what is the impact of global warming in Zurich, the city I currently live in? The problem of querying several sources is an old problem, and a number of solutions are available. For example, we could use a search engine. A search engine will extract text and links from all data sources and will represent that information into a graph data model. Keyword and path expression queries are then available on top of that graph. A number of approaches in the literature describe how to implement semi-structured search engines. The results produced by such systems are ranked results. In our example, the top result is a job in climate change in the region of Zurich. As we see, the result produced is not exactly what we were looking for in the first place. The major drawback of search engines is that the query semantics provided by these systems are not precise. We could use instead an information integration system. Such systems provide precise query semantics because schema mappings are established between the schemas of the data sources and the schema of the information integration system. That may be a global mediated schema in approaches such as GOV, LOV, and GLOV, or the schema of a peer in peer-to-peer approaches. The answers produced by an information integration system are precise answers, but that comes at a cost. Creating the schema mappings is an expensive process which requires human intervention. So the main drawback of an information integration system is that too much effort is necessary to provide schema mappings. In fact, for a number of data sources, schema mappings may be missing, and the information in these sources is simply unreachable by the information integration system. The research challenge we're looking at in our paper is whether there is an integration solution in between these two extremes. Must we always use a search engine or an information integration system? Or is there a new type of system that can combine the best of the two worlds? We believe the answer to this question is yes. We will use a new system abstraction called a dataspace system. When a dataspace system is started, it looks pretty much like a search engine. It extracts text and links from all data sources and represents that information into a graph data model. Queries may be posed on top of that graph. Again, we use keyword and path expression queries just like in a search engine. Unlike a search engine, however, over time we may establish relationships on top of the data graph. This process is termed pay-as-you-go information integration. With pay-as-you-go information integration, the dataspace system is able to provide a mix of ranked and precise query answers. Pay-as-you-go information integration is the main subject of our paper, and it is a key contribution towards the dataspace vision of Franklin, Halevy, and Meyer, published almost 2 years ago. Our method for pay-as-you-go information integration is called iTrails. The core idea of our method is to add integration hints incrementally. In a first step, we provide a search service over all the data by representing the data into a general graph data model. This means that our approach works for a number of data representations, such as XML and relations. In a second step, we add integration semantics by providing hints on top of the graph. These hints we call trails. As the trails are provided on top of the data graph, our approach works across data sources and not only between sources. Whenever more semantics are needed, we just add more hints, that is, more trails. The impact of our method is that we provide a smooth transition between search and data integration. Semantics may be added incrementally by adding new trails. Every time we add a new trail, we improve on precision and recall of the search engine. You may find more details on our approach in our paper. Thank you very much for your attention.